Hi there, this is Math 8, Unit 4, Lesson 7, called All, Some, or No Solutions. It says let's think about how many solutions an equation can have. How many can they have? Alright, so which one doesn't belong? First of all, we take a look at these equations here. We have to decide which one doesn't really fit or work with the pattern here. We notice on number 1, they both have a 5 and a 7, a 5 and a 7, so that seems to be okay. Here we have 5 times 7 and 7 times 5. That works out to be the same, no problem there. 7 minus 5 is equal to 2, so 2 has a value of 2. That's going to be okay, no problem there. And over here, 5 minus 7 is actually negative 2, and 7 minus 5 is positive 2. And those cannot be equal, actually, so we would say that this one does not belong. It just doesn't quite work out when you actually do the math. In section 2, we have a series of equations here. We have about 8 equations here to talk about their solutions. And it says to sort these equations into 2 types, true for all values and true for no values. So true or basically not true, like it'll work or it won't work. So example, for the first one, for n equals n, this would be true for all values, right? We can make n equal to any number we want, and because it's on both sides of the equal sign, it would work for any value of n we chose. Over here, we have 2t plus 6, and if we distribute this out, this becomes a 2t plus 6 as well. So again, they're equal on both sides of the equal sign. We have the same exact expression on both sides of the equal sign. So this would be true for any number n or t we choose. Okay? On this one, we have 3n, and then 3 times 1 is actually 3. So 3n plus 3 equals 3n plus 1. Now if you think this through, these would be eliminated, and would 3 actually equal 1? No, it wouldn't. So no matter what value we put in there, we're not going to ever have a solution for there. So it's not going to be true for any number we could select. Down over here, if I multiply everything by 4, I'm left with 20d plus 4 equals 20d. Now again, the problem here is that I have the 20d's that go away, and I'm left with this 4. Okay, that's a problem. So that means there's not a number we could put in with a d that's going to make that 4 magically go away. It's not connected to anything. So we say it's not true. It's true for no values. No values make it true. On this next one on the top here, we have 5 minus 9 plus 3x and negative 10 plus 6 plus 3x. Again, the 3x's cancel each other out. So you're left with negative 10 plus 6, which is negative 4. And 5 minus 9 is a negative 4 as well. So we have negative 4 plus 3x, and then a negative 4 plus 3x. What am I missing here quick? 5 minus 9, negative 4, negative 10 plus 6, negative 4. So that looks like it would be true for all of them. On my notes I wrote down not. I'm not sure why I wrote that down. Because 5 minus 9 is negative 4, negative 10 plus 6 is negative 4, 3x, it's going to be balanced on both sides, we're okay. Over here, the x's go away. We can't say that a half equals a third. That would be a not true. And here we have 6 times 3, and negative 6 times negative 3, which is positive 18. So we have 18y, and here we have 18y as well. So that's going to be balanced on both sides. That would be true. And here we have a 2 and a negative 2. That would not be true. Okay, so what we're looking at really is trying to set it up so that we have equal values, equal expressions, and the equal sign actually means equal. So on this one, it says write the other side of the equation so the equation is true for all values of u. We want to write something that would be basically the same. So we could write something like, and there's different options here, I could distribute and say 6u minus 12 plus 2, and distribute that out and rewrite it there. That's going to be true for all values of u. I could also rewrite that as 6u minus 10 and take it a step further, and even though they don't look the same, it would be true for all values of u. This is just probably the easier way of writing that down. If I want to make one that's not going to be true for all values of u, or for no values of u, then I need to set it up so that I have a 6u, right? That works out okay. And then over here, I end up with a minus 10. I could do a minus, in this case here, I could do minus 6 plus 2 instead of the minus 12. That's going to result in something completely different, and I'm going to have the 6 u's cancel out, but the numbers aren't going to be able to cancel out, so it's not going to work there. Let's look at the next section. All right, 7-3. What's the equation? We're going to skip this part right here. We're going to do the what's the equation 7-3. Complete each equation so that it is true for all values of x. We want it to be true for all values of x. In order for that to work, we need to pick a number here that it's going to match this side over here. So here I have 3x plus 6, and here if I distribute I have 3x, and I want to multiply by a number so I end up with a 6 there. So in this case here, 3 times what number is going to give you 6? We would say 2. 3 times 2. We can put a 2 right there. For here, I have x minus 2 on this side, so here's my negative x, and I'm going to distribute the negative throughout. That becomes a positive x, so I need to come up with a negative 2. If I put a 2 right there, a negative times a positive would be a negative 2, and that's my solution there. So I have a 2 for A, a 2 for B. Now over here, if I divide this out here, let's think this through, okay? This becomes 15 divided by 5x becomes 3x, and then negative 10 over 5 becomes negative 2. So I want to have a number that goes there, and so I can just simply take the 3x and put it right there and say, let's call it 3x, and we're good to go. For the other ones, on number 2, we will look for ones that no values are going to work. So any other number we choose could work. So it's the same equation. So instead of putting a 2 here, I can put a 4 there, and it's not going to work because that's going to become a 12 being equal to 6, and that just won't work there, will it? Over here, I could say, again, I could say 3, and that won't work because I'd say negative 2 equals negative 3, and that's not going to work. And again, over here, any number I want, I could say 5x, and that won't work because 5x minus 2 is not going to equal 3x minus 2. It's just not going to be the same. We're going to have an issue there, and it's just not going to work. Okay, so that's the idea there. So describe how you know whether an equation will be true for all values of x or true for no values of x. If it's all true, then we're going to have equivalent expressions on each side. Okay, if it's not true or no values, then we will have they will be not equivalent expressions. Okay, so in summary, an equation is a statement that expresses that two expressions have an equal value. Okay, so an equation is a statement that two expressions have an equal value, and that's what we're looking at.